Hey students, we are working today on Chapter 1, Lesson 5, and this one's called Greatest Common Factor. So taking what we learned last time with prime factorization and moving on to common factors. So our learning target today is I can find the greatest common factor of two or more numbers. So in our notes, we'll go ahead and get this set up here. Make sure your book is open to page 32 today. And we'll start by getting our learning target in the top right-hand corner of our journals. All right, once again, we're going to start with I can find the greatest common factor of two or more numbers. Okay, so to start out the lesson today, we're going to talk a little bit about what is a greatest common factor. So the abbreviation of it, and you'll see this a lot or say it a lot once you don't want to say the whole thing, is GCF. Find the GCF, or find the greatest common factor. So we'll go ahead and write it out completely now. GCF stands for greatest common factor. And a factor gets mixed up with a multiple a lot, very often. And so what I like to remember is a factor is below the number. And when we get to multiples later on, multiples are above the original number. So today we're going to be looking at numbers below other numbers. So with that being said, we can go ahead and start some examples. Oh, one more thing, this word here, common. Of course, if we're trying to find something in common, both things have to share this factor. And if we're looking for the greatest common factor, it has to be the highest number on our list. So we'll go ahead and switch colors and get to some examples. So we're on page 32, looking at example 1. It says find the greatest common factor of 24 and 40. And we're going to do this on this example by creating lists of factors. There's a couple different ways you can do it, but if we just want to create a list, we're going to try and find the GCF, or greatest common factor. So the two numbers we're looking at are 24 and 40. So I like to put both numbers at the top and make lists underneath them of all their factor pairs. So let's just look at 24 first. So we're going to think about all the different ways we could multiply two numbers to get to 24. So we could multiply 1 times 24. We could multiply 2 times 12 to get there. We could multiply 3 times 8 to get there. We could also multiply 4 times 6 to get there. And that is it, I believe. So we have 4 factor pairs for 24. For 40, our list would be 1 times 40. 2 times 20 would get us to 40. We could do 4 times 10 to get us to 40. And we could also do 5 times 8 to get us to 40. So we also have 4 factor pairs for that one as well. So now we've got the factor pairs for each number. We need to now figure out, so we've done the F part of GCF. Now let's circle all the common ones. They both have a 1. They both do not have a 24. They both have a 2. They both do not have a 12. They do not both have a 3. They do both have an 8. They do both have a 4. and they do not both have a 6. So out of the ones we've circled, those are the commons. Now we'll look at the greatest one. So the one that is the highest value would be 8. So the greatest common factor of 24 and 40 would be an 8. And that's how you find the greatest common factor of two numbers, by using a list of factor pairs. Now, sometimes a list can get really long, so there's another strategy you can use as well. So we're going to change colors and look at example 2. All right, so for example 2, in the book on page 32, it says finding the greatest common factor using prime factorization. So we're going to use prime factorization here to find the GCF. So the two numbers we're dealing with this time are 12 and 56. So again, I'm going to start out by listing them both at the top. But this time, if we're going to use prime factorization, we're going to go back to this factor tree idea that we did in our last lesson. So let's factor out both of these numbers all the way down to their primes. So how we can get to 12, it would be 2 times 6, and 2 is prime, so I'm going to circle it. The 6 can be multiplied out with factors of 2 times 3. And both the 2 and the 3 are primes, so we're going to circle both of those. So we're done with this one because all the bottom ones are prime. If we go over and do the same thing for 56, one way of getting to 56 would be 7 times 8. And 7 is a prime number, so we're going to circle that. A way to get to 8 would be 4 times 2, and the 2 would be prime. And 4 can continue by going 2 times 2. And now all of the bottom row has primes on this one too. So we've listed the factors now of both numbers. So now we're going to look at what they have in common. So if we look at both lists, this factor tree has a 2, a 2, and a 3. This factor tree has a 7, a 2, a 2, and a 2. So we both share a 2, and we share another 2. They don't both have a 3. They don't both have a 7. And they don't both have another 2. So if we look, we've underlined 2 2s over here and 2 2s over there. So if we come over here, 2 times 2, there's our 2 2s. Our factor that would be the greatest common factor between 12 and 56 would be 4, because they both share 2 2s in common. So that's how you use a factor tree to find the greatest common factor. So if you want to choose some on your own questions to try out, you can go ahead and do that at the bottom of 32. Pause the video and work on those if you have some time. And number 1's answer, if you had some time to work on them, is 4. Number 2 is 18. Number 3, there's 3 numbers there that you had to use. Number 3's answer is 7. Number 4 is 5. Number 5 is 2. And number 6 is 15. So moving on, our next example, example 3, is about finding two numbers with a given greatest common factor. So if we change colors here, let's go ahead and scroll on down. Okay. So the question says, which pair of numbers has a greatest common factor of 15? So what they've told us here is that the greatest common factor equals 15. So we know the final answer. So what we have to do is kind of work backwards and figure out what are the two numbers. So we have 4 choices here, an A, a B, a C, and a D to pick from that they've given us. The first choice is 10 and 15. The second choice is 30 and 60. The third choice is 21 and 45. And then the last choice is 45 and 75. So we're trying to figure out which one of these pairs has a GCF of 15, meaning it's a factor of both numbers, and it's the biggest one they have in common. So let's take a look at our choices here. 10 and 15. Well, if we think about it, 15 is a factor of 15, but 15 is not a factor of 10 because it's not lower than 10. So we know that this one is not it. If we look at B, 15 can go into 60, and 15 can also go into 30. So 15 is a factor of 30 and 60. Not sure if it's the most, or if it's the greatest common, but we're going to continue on. But this next one, 15 can go into 45, but it cannot go into 21. So we're going to say no to that one. And lastly, we have 75 and we have 45. 15 can go into both of those. So our options now are between B and D. So if we take a look at our different ways we could figure this out to see if which one is the greatest common factor. If we factor tree out the 30 and the 60, we could go 15 times 2. That's prime. And we could go 3 times 5. Okay, so those are all primes. If we factor out the 60, we could go 6 times 10. 6 can be divided up into 3 times 2 with primes there. 10, we can get there by going 5 times 2. And there's our primes. So let's look and see what they have in common. We have a 3 here and a 3 here. We have a 2 here and a 2 here. And we have a 5 here and a 5 here. So they all share a 2, a 3, and a 5. So if we listed those out, 2 times 3 times 5, let's see if that would get us to 15. 2 times 3 would be 6, and 6 times 5 is 30. So 30 is actually 30 and 60's greatest common factor, not 15, which means this one cannot be it. So our final answer has to be D, 45 and 75. If you wanted to double check that this is correct, you could go ahead and do the same thing we did here with 45 and 75 as our factors and do the tree or list their factors. This one, you only have to do one because there are 4 choices. All right, so next, if we look in our book on page 33, we have one more example about piñatas. So we're going to change colors here. They always give us one at the end that's more of a real life application to figure out when we would actually use this in our world. So example 4. So reading this one, my eyes are looking at page 33. You're filling piñatas for your sister's birthday party. The list shows the gifts you are putting into the piñatas. You want identical groups of gifts in each piñata with no gifts left over. What's the greatest common number of piñatas you can make? So really, we're trying to find the GCF here. So we're talking about piñatas. And we're talking about how many we can make. Now, if we take a look in the book on page 33, they have a little piece of paper there that tells us information we need. It says there's 18 bottles of nail polish. So we know we're going to have some nail polish. And there's 18 of those. Then we have 24 pairs of earrings. 24. And it says 42 lollipops. It's interesting items inside of piñata here. So if we wanted to try and figure out the number of piñatas we can make with the same number of each of these items in each one, we really need to figure out the GCF, greatest common factor. That will tell us how many total piñatas we can make with no leftovers. So let's go ahead and factor tree these out, or list their factor pairs. You can do it either way. I tend to prefer factor trees, but if you want to list the factor pairs, you can do that too. 18 can be divided by 2 times 9, and 2 is prime. 9 can go 3 times 3, and we have all primes on the bottom. 24, one way to get there is 6 times 4. Then 6 can go 3 times 2, primes. 4, 2 times 2 to get to 4. And that one's done. Coming over here to 42, we can cut that one by going 2 times 21. 2 would be prime. We can keep on going. 21 would be 3 times 7. Now we have 3 numbers to look at here. So when we're trying to find GCF, we need to make sure that they are happening on every single list. So I have a 2 here, a 2 here, and a 2 here. So I'm going to list a 2 as one of my numbers that I can use. I have a 3 here, a 3 here, and a 3 here. So I can list a 3 in my multiplication. I have another 3, but I don't have another 3 to use in these other ones. And so I can't really do anything else because there's no 2s in this list. There's no 3s on that list. There's nothing else that all 3 lists share. So basically, I'm down to having to go 2 times 3, which is 6. That means I can make 6 piñatas if I want equal amount of each of these items in there. So what does that mean for each item here? If I have 6 piñatas and there are 18 nail polishes, 18 divided by 6 piñatas, that would be 3 nail polishes in each piñata. If I have 24 earrings and I have to divide those up into 6 piñatas, 24 divided by 6 means I would have 4 pairs of earrings in each piñata. And lastly, if I have 42 lollipops total and I have 6 piñatas to divide them up into, 42 divided by 6 would be 7 lollipops in each piñata. So this would be my totals in each piñata. This is my total number of piñatas created. If you'd like to try the on your own, number 7 and 8 at the bottom of page 33, go ahead and pause the video now and do that. So number 7 says, write a pair of numbers whose greatest common factor is 10. One option would be 10 and 20, but there are definitely lots more options than that if you're checking your answers. And number 8, in example 4, you add 6 more pairs of earrings. Does this change your answer? So if you did everything else in example 4 the same, you just add 6 more pairs of earrings. Your earrings now, instead of 24, would be 30. This does not actually change your answer. The prime factorization of 30 is 2 times 3 times 5, so you would still have a 6 as your GCF. So that would be the answer to number 8. That concludes our lesson 5 video. If you want to look at some practice problems, 34 and 35 in your book would be the practice pages, and we'll work on those in class as well.